Hello everyone, welcome back to my channel. I am Kaustav Datta, USN 1VE23 CS082, branch CSE, semester 4th, section Bhaskara. So today's video is going to be on the topic 01 matrices and directed graphs for the subject discrete mathematical structures bearing subject code BCS 405A. So we will be exploring the fascinating connection between matrix algebra and graph theory and discovering powerful applications in computer science and operational researches. So let's start the presentation. So let's start with a quick definition of 0 1 matrices. So a matrix where every entry is either 0 or 1 is called a 0 1 matrix. These matrices are representation of binary relationships. So they are commonly used for adjacency matrices in graphs and representing binary relations. So one example of a 0 1 matrix is this one. As we can see here, there are two elements in a matrix, and inside the elements these are also in turn array on a matrix. So 1 0 and 0 1, these are two elements of the outer matrix. This is a simple unitary matrix. It shows entries are either 0 or 1. So what are directed graphs? So whenever we talk about graph, there are 2 points to remember. One is vertices and another one is edges. So vertices are nothing but the nodes, and edges are the connections or the arcs that we use between the nodes. So as we are talking about directed graphs, so in directed graphs, direction also matters. Direction is the important thing. So for example, in a graph, if we go from node A to node B, this is not the same as going from node B to node A. Because for example, if we take a graph of three nodes, a directed graph of three nodes, A, B, C. If we say A to B is 20, B to C is 10, and C to A is 30, we can't say if A to B is 20, then B to A is also 20. For going from node B to node A, we need to follow the path of B to C and then C to A. So B to C, as I've told, is 10 and C to A is 30. So A to B is 20, but B to A is 40. Why? Because it's a directed graph and direction does matter here. The representation, they can be showed as an adjacency list or an adjacency matrix. So this one is an adjacency matrix, as you can see. 0 1 we use adjacency matrix representation. Graph to matrix, a 0 1 matrix represents a directed graph connection. The entry rule is, suppose if a vertex is present or an edge is present for the nodes I to j, then we can say a of ij is 1. If it's not present, then we can say a of ij is 0. So if there is a path, it's 1. If there is no path, then 0. For example, vertices 1 2 3 and edges 1 2 2 3, the matrix is 0 1 0 0 0 1 0 0 0. So now let's talk about paths and connectivity. A path is a sequence of vertices connected by edges. And reachability, vertex j is reachable from I if a path exists between them. Connectivity matrix, C of ij equals to 1 if j is reachable from I, otherwise it's 0. So as I have told previously only, if there is a path from I to j, if there is a path from I to j, that is j is reachable from I, then only we can say 1. If there is a path from j to I, that is I is reachable from j, but j is not reachable from I, like there is no directed edge for going from I to j, then yeah, it's 0. But if there is a path, it will be 1 in the adjacency matrix. Computing the connectivity matrix, matrix parse. A to the power k of ij equals to 1 indicates a path of length k exists. Total reachability, C is a logical OR of a square, a cube up to an. Efficient algorithms. Warshall algorithm computes the transitive closure efficiently. So there are many algorithms to compute shortest path or the maximum profit of a graph, but like what we are referring here as Warshall algorithm only. There are many other algorithms like Prims, Warshall, Kruskal, then Dijkstra. Many algorithms are there. Dijkstra is the best algorithm to find the shortest distance. Like it's a distance from a single source, so it's the best one, the most efficient one. But here we are using Warshells only, no problem. It's also find the transitive closure effect. So other problems are also there, like we can use knapsack algorithm also to find the maximum profit. Yeah, so many applications are there for finding the shortest path. Now let's take an example of social network. So in social media network, you have seen users and followers, right? So the users are vertices and the follows are the directed edges. So we can see who is following whom, how many followers, how which post is a user liking, what story is he putting on in his account. All everything, all the data of social media network are like connected using directed graphs. So adjacency matrix represents who follows whom in the network, shows who can see whose post or reachability by connectivity matrix, and applications are influence analysis and recommendation system using this. So you can see that Instagram or any other like Facebook, Instagram, Twitter, all this provides ads, right? So how are they providing? How are they recommending that this person should see this ad only? Because all the data are connected using a directed graph. So whatever activity you do on your social media account, it will be displayed, and it will be used for recommendation systems, it can be used for analyzing systems, it can be used for social media. So the ad which you are getting recommended is because of your activity only, and all these are due to graph networking. So other applications are scheduling. Tasks as vertices. Task in a project becomes a node in the graph. Dependencies as edges. Edges represent the required orders of tasks. Topological sort. This order tasks to satisfy all dependencies, and critical path identifies the longest path, determines project duration. The properties and theorems. So strongly connected, every vertex is reachable from every other vertex. Condensation graph represents strong connected components as nodes. Acyclic condition. A graph is acyclic in its adjacency matrix is nilpotent. Acyclic means that the first node and the last node is not directly getting connected to each other. If it if it is connecting that, yeah, if a closed chain structure is forming between the nodes, then it's a cyclic one, but a directed graph should be cyclic. So I would like to conclude my presentation here. So I can say that zero one metrics and directed graphs are essential and powerful tools. From social networking to complex scheduling problems to recommendation systems to AdSense properties, everything is defined by a graph data structure. So NoSQL uses graph as a prevalent database schema because of its variety of usages. So yeah, this supports that directed graph is one of the most important schemas for odd data structure for storing and sharing and getting the data. And the further studies may include spectral graph theory, network analysis, and advanced algorithms for directed graphs. So yeah, I would like to end my video here. If you like the video, then please like the video, and if you found this content relating to what you want to study, then you can subscribe to my channel for more such contents. Thank you.